And welcome aboard November 147 Bravo Romeo. Today we're going to be demonstrating using the automatic calibration feature of the on-speed system using our EFIS as the primary reference for achieving that calibration. Now, the very first thing we're going to need to do with our phone or our tablet is make sure we go into settings, and we want to disable any sort of auto lock because we don't want the phone turning off right in the middle of a run. So I've got my auto lock set to never, and I've got my brightness full up because I'm under the canopy today, and it's I need as many nits out of the phone as I can get. Once I've done that, the next thing I need to do is just connect to the on-speed network. If it's the first time I connect, it's going to ask for a password. If I've connected before, it's not. The password is angle of attack, all lowercase, one word. We're connected to the on-speed network. The next thing we're going to do is pull up the Wi-Fi Gateway. The way we're going to do that is by typing on-speed local into the address, and then the home page will open up on the Wi-Fi Gateway. Let's take a real quick look at our settings because we're going to have some homework we're going to do before flight. First thing we're going to need to determine is how many flap curves we're going to need for our airplane. So I've got 3 flap positions I use. I use flaps 0, flaps 20, and flaps 40. So what I've done is I've put 3 different curves in the system, okay? And then I've measured my flap potentiometer, or my flap sensor value at each setting using the read function. Now we can do that on the ground by holding the trailing edge of the flaps up, or better yet, we can do that in the air under air load. So I've already done that for each 3 of our flap positions, so we're ready to go there. The next thing I want to make sure is that I've got my calibration data source set to EFIS. So I toggle down, or I scroll down rather, and we're set to EFIS. If I need to save this, let me just show you an ism here. The first time I touch the screen, it brings up the browser. So I have to actually hit save twice for that to work. Now our configuration is saved, and we got a warm fuzzy, everything is good. We're going to turn to the left here just for some airspace. I'll expedite that turn just so we keep the sun out of our eyes, and then we'll start to talk about our AOA Calibration Wizard. Now you may want to consider using an assistant for this so you can concentrate on flying and they can work the phone or the tablet, and you may want to engage your autopilot as well. I'm just hand flying everything today to expedite. Okay, next thing we're going to do is bring up our AOA Calibration Wizard. It has 3 pages. The very first page is going to be some data that we're going to talk about populating, and we should have that homework done pre-flight. But the first box is our aircraft gross weight. The second box is our test gross weight, and I'm going to adjust that from 1315 to 1310 just to demonstrate how to do that. Done that, it's in there. And then that'll take us up to the second page. And I apologize, let's just go back because I wanted to show you that we get the 1310 in there, and then we need to get our best glide speed in, and that's a gross weight and knots indicated airspeed, so that's 78 for us. That's an LRD max condition flap 0, and 6 Gs for our airframe limits. After we hit the continue button, that'll bring up the second page of the display. That is just a set of instructions. So we'll talk about that real time as we go through it. Let's toggle to the third page, and this is the meat of the mission right here. This is the actual AutoCal page. We're going to hit the record button to begin the AutoCal sequence, and we've got our AutoCal deceleration gauge on the phone in case we don't have the optional M5 display up here. Now I have the M5, and I have the deceleration display up here. I have mine relatively smoothed, and I'm checking for flaps 0 just to make sure everything is set up. I'm going to set that on my knee to actually fly this. We're going to get accelerated down here. I'm at 5,000 feet pressure altitude with 2992 set. The time is 12:56:08 Zulu, 68 degrees Fahrenheit. I've got 24.9 gallons on board. I'm heading 360 degrees, and I'm approaching a VNO condition, which is where I want to be to start my calibration. I'm level at 5,000 feet VNO. Standby data mark 3, 2, 1.
Data mark.
That's optional. I'm just putting a data mark in the system, and I'm pressing the record button. Pulling the power back. Nice smooth pull. There's 6 seconds, 7, 8, 9. And I'm just keeping the pitch picture out the window the same through this initial part of the deceleration. And there's 13 seconds to get the throttle back to idle. I'm not really trimming yet. All I'm doing is letting the stick float back in my hand, and I'm starting to increase back pressure just to keep that sight picture the same.
Just the procedure turn course reversal there.
And I'm not in a hurry to add the back pressure, especially in an RV. The airplane's very slow to slow down.
Square 13 out of 4,000, 3,000.
Now if I look at my decel display, I'm approaching that 1 knot per second, which is exactly what we want for this. I'm just gradually increasing the pitch. I'm not trimming. You can see my nose is approaching the horizon. I'm holding this 1 knot per second, not concerned with my altitude, plus or minus 500 feet is fine. As I slow the airplane down, I need to increase the pitch rate to keep my deceleration in the middle of the green band. And again, it's just a target. It's more important that you're smooth on the pitch increase than the exact deceleration rate. As we approach the stall, I need more stick. And then there's the stall, get a good wing drop. And if my button turns back to blue and I have a curve down at the bottom, I have a good calibration. And my R-square value is 0.9988, doesn't get much better than that. I've got a nice little concave curve. So the very first thing I'm going to do, in case I need tech support, is take a picture of that. So I'll get a quick screenshot. I got too much trim in there. I don't want to lose control of the airplane. Okay, so once I get my screenshot, the next thing I'm going to do is save data to file. And that just puts the data file on the phone in case I need it, again, for tech support. And then the very last thing I'm going to do is save the calibration. Once I save the calibration, it's going to input it and see success. Calibration was saved, closed, and that calibration now is in flap curve 1. So I can go to system configuration, pull that up, takes a moment to get there, flap curve 1, and there's the numbers that we just input. So we've got our good curve down at the bottom. It's a second order polynomial curve, and we've got our LVD max, on speed fast, on speed slow, and stall warning AOAs. The next step is to go in there and check those set points, and that'll be the topic of a different video. Thanks for watching.